Right, so this is the indirect pathway, and this is inhibitory with the aim for less movement. So as we said earlier, the thalamus is always looking to stimulate the cortex. So, but we want to stimulate it for less movement. So, like with the direct pathway, we're going to have this. Our final message is going to be from thalamus to cortex, but we want decreased levels of glutamate, so it is less excitatory. Okay, so again, I've drawn in the dots. We're going to join the dots. So as always, we start at the cortex. So message coming down from the cortex into the putamen of the lentiform nucleus. And so we've got increasing levels of glutamate. So it's excitatory, right? And then the next neuron, if this is an inhibitory GABA releasing neuron. So if that's excitatory, okay, it's gonna excite the next one. So the next one is going to release increased levels of GABA. So increased levels of an inhibitory neurotransmitter. This is where it's different from the direct pathway. This neuron just goes as far as the globus pallidus externus, where it synapses again. Okay, and this part, and this is where this is the indirect part of it. We have to take a diversion. We have to go via the subthalamic nucleus. So we've synapsed in the globus pallidus externus, okay, and our neuron is going to head over to the subthalamic nucleus. So if this is increased levels of GABA, it's more inhibitory. So what does that do to the next neuron? It means it releases less. So it inhibits it. So it's releasing GABA, but less of it. So it's releasing GABA. So you've got decreased levels of an inhibitory neurotransmitter. So what does that do to the next one? Well, it means the next one now has increased levels of glutamate. Oh, that's a wobbly one. Okay. Yeah. So decreased levels of GABA, decreased levels of the inhibitory means the next neuron in line is less inhibited, so it can therefore release more of its neurotransmitter, which is glutamate, which is excitatory. Okay, so we want this excitatory glutamate to be released because the next neuron is a GABA releasing neuron. So we are going to be releasing, therefore, increased levels of GABA. So if we have increased levels of GABA, that means more inhibition. And what is the aim of the indirect pathway? Less movement. So we're going to increase our inhibitory neurotransmitter, which means the next neuron, which is an excitatory one, but it will be releasing less glutamate, less excitation, less movement. So that is sending less movement to the cortex. So again, what you're looking at, what is happening to the next neuron in line. So if if you get stuck, you can work backwards. Yeah? You can start with this. You know you want less movement in the cortex, so this one's got to be decreased. Then you can work backwards. Easier to remember it forwards, but if you get stuck, you can go backwards. So there we go. Let's just label these bad boys up. So we'll run through it again. So we have excitatory signals from the cortex going to the putamen of the lentiform nucleus. That stimulates increased levels of GABA. Then we synapse again at the globus pallidus externus. So then we head down to the subthalamic nucleus. Okay? At the subthalamic nucleus, we go back to the globus pallidus, but the globus pallidus internus, that is step 4. Then from the globus pallidus internus, we head back to the thalamus. Then from the thalamus, to stimulate the cortex for less movement, that is the last part. So this has got 6 parts. So indirect pathway includes the subthalamic nucleus. Is there anything else I need to add to that? Let's just have it. Oh, excuse me. Excuse my arm. Right. No, that's that. Indirect pathway.